Good evening, all. Oh, this camera might have moved a bit. Let's see. There. Good evening. How are you all doing? Let's see. Is my microphone working? It is. Let's turn down the music. And I found that it was still a bit too loud in previous streams, so I've turned it down more. While we're doing the pre-stream, I'm already going to assemble some stuff because I've been packing for my trip to China, which will be not tomorrow, but the day after, so pretty soon. And yeah, that's why a lot of stuff that was on my desk isn't on my desk. So now we need to prepare some stuff. Because, wait, why are I not 60 FPSing at all? There we go. Okay. This is a Sender-7. This is the prototype we've been using. Another one I already packed. But this is the abused one. This is what I did all my testing with. So we'll be using that again today to do even more testing. The testing things you shouldn't do. We have a sacrificial switch here. It's a little MikroTik router board switch. It's a 250 GS. It's a really old one, and well, it deserves to die really, because I tried to use it a few years back, and I got strange results while developing the Ethernet version of the Dig-Octa. Well, there's only one version. And in the end, it turned out to be the switch. So that cost me like a few weeks to figure that out. So if it dies when applying power with Diff-Power, that's fine. You know, kind of deserved it. I honestly do not know what's going to happen. My detection mechanism, it tries to detect a remote board, but it's not that sophisticated. There's no negotiation or anything like that. So it might just trigger, and then it will send 55 volts straight over those UTP or those Ethernet pairs. And, you know. Okay. Right, so we need some standoffs for this. Did I tune the music down so far that there's now no music? Maybe I just need to increase my own voltage. Voltage, yes, my voltage. Well, my voltage to my headphones, called volume. Right. Let's get some feet for this guy. We can use this as feet. Good evening, all. Oh, I didn't do any road call. How do you call that? The Tennessee call. Hold on. Let me find some screws. These are all different screws. Well, it doesn't matter too much. Yeah, no, I don't like these screws. Okay. Let's see. M3 by 10. That's a bit long. M3 by 6. That should do it. Easier to avoid spoilers on my stream. What? I spoiler stuff all the time. So let's see who's all here. Well, no, this has to go in here. Let's see here. We have Yako Weesus first, and then Nigel Young. It's going to be good tonight. Maybe. We will see. Excited for these days, says Timothy. Good. Second, to slam the like button. Wow, 12 have already slammed the like button. That's awesome. I was first. Just proof that Quinner doesn't like his own stream. What do you mean? Why this hostility? It's still 23 degrees outside. Yeah, it's warm here too. And guess what? The air conditioning in our bedroom failed. And we have a attic bedroom. So during the night last night, it was 28, 29 degrees up there. That was not fun. Not fun at all. So today I called some airco installation peoples, and they were all like, yeah, maybe in a month's time. We're kind of busy. And I was like, that's a problem. So, yeah. We have a temporary solution right now, but I think the gas in the air conditioning gave out. It's 8 or 9 years old now and hasn't had a lot of service, so that's probably it. Anyway, I didn't sleep much. I've scheduled my stream to clash with the Miami Grand Prix Sprint qualifying. Well, it's only qualifying. This is the actual stream. It's not a qualifying stream. So, I mean, what are you going to do? Okay, so now the board has feet. That's good. I like it being off the desk a little bit. But it also needs some standoffs for the brain board to go on here, like that. I did organize this a little while ago. M2.5, yeah, but I don't need with screw things. I think 3 centimeters should be good. Oh, my chat is stuck. Oh no. Huh. Sup live while watching my newly arrived Bamboo Labs H2D. Wow. Big spender here. Oh, now I also need screws for this. These should do. Oh, that's a bit too much. Yeah, watching me and Grand Prix, that's like the best combination ever. Constant excitement. No, wait, I need more screws. What am I thinking? I want to use these. These are nice. 5 times 8. That's a bit much. The second favorite Dutchman, I am honored. If I'm the first one, though. That's assuming. Sorry. You named your son after Verstappen. Cool. Okay. Yeah, I'm not much into any kind of sports, really. Never been my thing. You can't beat triple 4K monitors. Yeah, that's true. I upgraded the 48-inch OLED to, well, upgraded, it was dying, so, to two 32-inch 4Ks. It's actually a bit too wide, I think. I should maybe have gone with 27s, but I don't know. I noticed that I'm not using most of the screen, no, I'm using all of the screen, but there are some hot spots, basically. Where I use it most. But we'll see how long these last. Who knows? A major AC upgrade. Well, we have whole house cooling with the heat pump and underfloor heating, or currently underfloor cooling, except in the attic, which was designed that way. So that we just have a heat pump air conditioning there, that's fine. And that's always worked great, except if you don't service it for that long, and it seemingly the gas ran out or something, it's having an issue. So now, when it's suddenly hot and you turn it on, oh, okay, these screws are not magnetic. And it doesn't do anything, well, it kind of catches you off guard. Let's see, can I get the screw in here? Oh, this is a really old brain board I'm now noticing. This is a V1 Release 0 prototype. Oh, you never know what's on my desk. Should be fine. Okay. Some final torques. There. Okay, so now we have the brainboard stacked on the power board, just like a normal Dig Octa. I'm going to borrow this plug, because, you know, like that. And then we need 4 wires. Would these reach? No, that's too small, isn't it? Oh, yeah, we can use some of this. This is good wire. I've been preparing LED strips all week, so I have all kinds of cut-off samples. So if we put this here, I want to give it a little bend. I want to keep it here. Sure, somewhere there. We're going to use the scissors of doom. These, oh. There. They're awesome. Okay, we need 4. Let's see. Oh, I've got a pair of 3 and a pair of 3. Well, that's what it is. And, okay. Oh, we can make it loose wires. Okay. So let's screw these in. We're not using wire fills today. I don't know why. So the Sender-7 has a reason, and the reason is we're using I2C to control the sender board, and then you can't use LED 8. The ESP32 just doesn't have enough pins. There are some alternative combinations you could make, like on a newer brain board. There's a extra set of oh, here it is. Oh, here's another prototype. There's an extra header here, and you could actually steal some GPIOs from the SD card for that, and then you could still use it with 8 ports if you really want to. But then again, the Sender-7, I just couldn't make 7 or 8 channels fit, so that's why it's now a Sender-7 instead of a Sender-8. Can you use 8 output of the brain board with the other long-range Quinn LED solution while this board is on? How do you mean? So you can only use an LED channel once. Wait, didn't I have 4 wires? This is going to happen a lot today because I'm not really on my game. Whatever. There. Now we have 4 wires. Ah, here it is. Okay, yeah, well, now it's white. That's fine. Thanks, Rich. Rich, as I said, I had maybe 1 or 2 hours of sleep. Oh, no, I already took my wire strippers. Oh, we have some alternative wire strippers. No, this isn't it. This one. Let's see if we can make that work. Nope. Maybe it needs to... There's this adjustment thingy here. Maybe it needs adjusting. Okay. It did it. Yeah, but you shouldn't exceed 8 channels anyway. And actually part of the reason I made it like this, so you can wire it up manually, is if you want to run lots of LEDs, you're going to run out of processing power on the ESP32 pretty quickly. So you can actually use 2 brain boards on here while using a single Diff-Power sender. So that way, let's see, LED 1 goes into 1 to 4. Okay. So that way you can make sure you can utilize all the channels to, well, your benefit by just adding brain boards if you run out of processing capabilities. Thanks, Blake. That's very kind. So the brainboard currently still has the best solution that's also supported in WLED. There are some advances being made in moon modules with an ESP32 and S3 with octal PS RAM, but that has the disadvantage of not having a proper Ethernet solution. So in the end, it's actually questionable what's going to be faster. For generated effects on ESP32 S3 with the new code for moon modules would likely be faster. But then if you need Ethernet again, it likely wouldn't be. So yeah, that's a bit much to develop a completely new brainboard for that. Or a bit little, I guess. I have high hopes for the ESP32P4. That's the highest performance new chip. But when that will be actually market available instead of these current samples that you can get. And then we also need software support. That is likely going to be a little while. So, yeah. Okay, so now we have hooked up our LED output channels from this brainboard to these inputs here for channel 1 through 4 and 1, 2, 3, 4. We're only going to use channel 2 and 3 because, you know, I've manipulated all of those, and yeah, there are different configurations and stuff. The second thing we need is a plug from here. Let me see. Ooh. For the I2C, so SDA and SCL, we need to connect to here to SDA and SCL. Now, I have a nice little 3-wire cable here we could use. Because we'll also add some ground. It's always good to have extra grounds. There is all kinds of ground connections there, but, you know. Okay, I need to... These connections already need to change for the next revision. Oh. Because I messed up the order. The order the connections are in. So let's see, we have ground. Oh, this is okay. Nope. Oh god. This one should do. If it still has juice. It does. Good, 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 good. Now you're not really supposed to screw these in while it's in there, so let's not do that. Could this configuration be sound reactive? In theory, if you don't use the extra pins for the SD card, so this version with this alteration, you can then hook up a digital microphone to those extra pins, and you'll still have the 7 LED outputs available. But you need to think about if that's going to be useful or not. If you're only going to use it to transport power, etc., for something in the same room, sure. But if you're going to use it with longer cables for something that isn't in the room, the question is how useful sound reactive is going to be. Yeah, I know. I don't feel like ferals today. We're going to do it the hard way. Okay, so this is now done. Yep. Now we need to do it over here. I'm just kidding myself that these are going to stay together. There. Okay. How's the music versus talking mixture right now? Last time I found the music a bit too loud when I wasn't talking, so... Now I need to watch out how this is done. Should make a better solution for this, or an easier one at least. Oh. Level is good. Okay. So the I2C, the way I've implemented it so that you can switch on and off each channel, is optional because the default state is on. Right? So even if you don't have this I2C port, now I need to check. SCL is SCL over here. Almost can't believe I did that right this time. I don't know. Yeah, maybe. So by default, all channels are on, and the software basically allows you to turn it off. That way, if you don't want to bother with it and you don't mind the channels being on, that's fine. Okay, there. Let me get rid of this. Now we can use our little Ethernet switch here for the last time in its life, probably. So let's give that 24 volts. Cool, okay, very good. Thank you, Slizord. Lord, I don't know how to say that, sorry. Well, it's just extra stress on the terminals. There's no real danger. It's just, yeah, extra stress that isn't really needed. Could crack a solder joint, something like that. I always hate knots in my cables. So we're going to use this switch to link up the brain board, which I had trouble with this switch, so we'll see. Let's see if it still works. Power. Yeah? Okay, seems to get power at least. That's good. Okay, let's use this uplink. I think this is a gigabit switch, so that should be fine. Yeah, okay, we have a blinky light. Good. And let's take one of our Ethernet cables here. There. This goes into the brain, or the power board. No, wait. I need power first. Ground. Positive. Well, people are slowly coming in, or we're already well past starting time. Okay, so this goes into the brain board. Here we have the little switch. I don't know, like that. Yeah. Good. We first need to test the whole setup, because these are half new ports. So what is the rule still active if you can't say a name? No, sorry, that's not still active. I don't know when it was. 55 volt. Where's the safety glasses? Always the safety glasses. It's always the times you think, this isn't going to be a problem, and then it explodes in your face. Okay. 55 volt. Let's go. Beam. Okay. So it's trying to Ethernet. Oh, okay, now it did. So you can imagine that during development, if it flashes on and off like that, you're like, what the hell's going on? And then after trying for I don't know how long, you try another switch and it just instantly works, and it works on any other switch you try except for this one. Bad. Okay, let's see what IP it got. Yeah, okay, nice. 128. Good, okay, so I can take these off again. I watched someone talk through the configuration of MikroTik managed switches. Seemed like a big learning curve. Yeah, my whole network, so routing, switching, and wireless is all MikroTik, but I have somewhat of a networking background, so I like that. But I can imagine it being a steep learning curve if you are not into that kind of stuff. And I like being able to define everything manually. So yeah, that's why I use it. Because then it's great stuff for a fair price. So, okay. Let's show you the WLED console. Yeah, we can do this. Let's see. Display, no. Browser, yes. There. Okay, so this is a special build that I compiled myself. It is 15.1. Let's make that a bit bigger. 0.15.1 beta 2, which is currently, if you want to run version 15, the best build to run, because the normal version kind of has a problem with multiple outputs. Let's see here. We don't need a limiter. Right, okay, so when I flash this version, it shouldn't say 0, it should say unused, so that's a problem. And we don't need 8 outputs, so let's remove those. There. Actually, we'll need to remove all of them. Let's see, GPIO 0, 1, 2, 3. Okay, remove. Actually, port 1 doesn't exist, So let's start with this one and that one. Let's do 300. And let's do the other port too. Save. Okay, good. Unify is okay. It's kind of mainstream. But, you know, if you want something that works in a simple but still advanced, that's not a bad thing. I like the flexibility of MikroTik. I'm building it myself, so yeah. Let's see. I need to look up the I2C pins. So SDA is 32 and SCL is 13. So I go to user mods, and then we say, oh, we can't because digital mic is on there. Hold on, need to remove digital mic. Unused, 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 save. So, 32 and, what was it? 13 for I2C, which we're going to need to control the multi-relay mod. And we also want to use this. Our address is actually 61, and we want to use P0, P1, P2. Those are the internal ports of the port expander. P5, P6, and P7. Okay, save. Now that likely isn't going to work yet. Because we need to reboot it. Let's see, reboot. Is my chat on screen? Yeah. It should be. YouTube chat? Yeah. Okay. Oh, there it is. Okay. I was going to say, where's the chat? But it's here. Oh, okay. In theory, if we now turn off the power, nothing happens. Okay, let's check it. User mod. Oh, it didn't save for some reason. 32, 13, save. Let's see if it now saves. It did. Okay. Let's reboot it again. Yeah, the Ethernet really isn't happy. Anyway, so now we do have I2C, and now this thing is not enabled, use PCF, so let's do that, save. Okay, multi-relay, 8 relays, good, let's power off. Still not working. Configuration, user mods, okay, it is enabled, so now we just need to reboot again. I'm hoping that in the end I'll be able to deliver this pre-flashed and you don't have to do all this crap. Right, power. Still not working. Why not? User mod. Okay, it's enabled. I believe it's 61. Let me check real quick in a different browser. Let's see, Diff-Power Sender-7. Oh, okay, I got the I2C address wrong. It is 56. Save. Back. If I turn off power now. Ah, there it goes. Okay, so now if I turn off power, the external relay from the brain board turns off, but also the power LEDs for each of the channels of the diff sender output. So now we can control each of those channels individually. Now, software-wise, that is not really yet a thing, but I can show you if I set the delay 1 second higher for each output. Like that. And now I turn it off. You'll see some turn off immediately, and these turn off in sequence like that. See that? So we do actually have, and turning on is the same. We do actually have individual control, just the WLED software doesn't have anything that you can link it to segments or LED outputs or something like that yet. Sure, Drasal, of course, but you know, I will of course make videos about this system once it actually releases and things like that, to explain and show how to do all this. But in the end, if you can just, you know, install it using install@quinella.info, and these settings are preset, that is going to make things easier. The pinout guides and everything else will of course always stay available, but yeah. Right, so well, since I'm connected to the board right now, we've proven that this is a actual working switch. Let's hook up a output board real quick to show that the outputs are working. I have this one somewhat prepared, not completely prepared. Let's screw this in. Because it could also, you know, kill the output on the board. Who knows? Okay. Let's see. VCC. Do we want to try with the switch first or diff solo and diff advance? I kind of want to try with the switch first because that's likely going to give the most spectacular result. Hey, Pepsi's here. Forget about blowing up the diff stuff. Move to the blowing up the switch. Sure. I really wonder what's going to happen. I also have some other sacrificial switches we could use. Let's see here. This should be here. Let's double check. This is a 5 volt converter. Yes, it is. Good. Okay. Power diff. Yes. Today we're doing destructive tests with things you shouldn't do. So let's I don't know. Click this in here. Put this on the screen a little bit. And click this in here. Okay. Let's do some blends. Let's turn down the power a little bit. Okay, let's do rainbow. It's more clear. Where are you, rainbow? Here. Okay, so that is pretty clearly working just fine, right? Okay. Let's put on the safety glasses. Maybe you guys should put on safety glasses too, because, you know, I did that twice to struck the thing that is marriage, but okay. You should marry someone you like. Anyway, so what I'm gonna do, so this is all working, okay? So let's disconnect this part. We don't want to blow that up. And we have the diff power here. I'll turn off the WLED screen. Okay, now I am going to disconnect the switch from the uplink. And I'm not too concerned about the brain board. So the brain board is going to keep its Ethernet connection. Never go without safety glasses. Yeah, no. So I'm going to keep the Ethernet connection to the brain board, which may get fried because, you know, we're sending potentially sending 55 volt to the switch, but we'll see. We'll see. So I'm going to turn this way, and if there is an orange light that will start glowing over there, that is bad news. I'll take these out because the orange light is the remote board detection light. So if that activates, it will start sending power after a few seconds. Okay, something like that. Okay, there. Okay. Well, I'm just gonna plug it in port 5. Uh-oh. Yeah. Okay. Bad. Oh. Okay. The switch died. Well, it's not dead yet. It's pulling 24 watts from the wall. Okay, let's disable or turn it, take it back out. Okay, now it's pulling 15 watts from... Oh, I should have looked on my bench. Okay, well, the diff power seems fine. Oh, the switch seems fine too. That's interesting. Does port 5 still work? Well, that's normal behavior for this switch. Yeah, port 5 still works. So if I then connect my Ethernet, can I refresh WLED? I can. What? But it just got like lots of volts. Okay, let's try that again. So let's disconnect this. We're gonna use a different port. And we're just gonna, you know, put it in, okay, detection. Okay, so there was a lot of power draw because I think the brain board actually reset. A bit disappointed. Well, it's currently outputting power because this light is shining pretty brightly. Oh, wait a minute. This one is also shining brightly. I think it killed the MOSFET. Uh-oh. It's currently still doing 8.8 watts. Okay, so let's disconnect it. Now it's doing 2.7 watts. Okay, but we have a problem. These lights are not turning off anymore. That means that the either the MOSFET or the detection circuit is broken, but we don't see the orange light, so I think the MOSFET, it killed the MOSFET. So, okay, let's turn off power. Let's turn on power. Yeah, that's bad. MOSFET died. Let's turn off power in software. Oh, wait, we can't. There's no network connection. Well, we're going to still use port 5. Well, this is going to blip. Okay. Let's see. Can we... Yeah, port 5 still working. Okay, turn off software. Yeah, no. This is dead. Okay, so it actually kills the MOSFET. Interesting. Switch won't die today. No, seemingly not. We'll try another switch. I have another switch upstairs. I need to get it, which we can sacrifice. So let's see if the output channel still works. I actually think the output channel will still work, but I don't want to hot plug it now. So go. Yeah, okay, we still get orange. Let's do rainbow again. Rainbow. Yep, still got rainbow. So, output-wise, this channel is fine. It's just that the MOSFET is basically stuck on. So even if we turn off with software, and you can see the channels turning off here, the output light doesn't turn off anymore. Interesting. Yeah, and it's immediately on, even though maybe the channel wasn't on yet. Okay. So failure mode for plugging it into a switch kills the MOSFET. And I think while it was doing that, I heard like ticking noise real fast. So it likely switched on and off real fast, which would kill the MOSFET. Okay. But now we have 2 dead channels, and I don't have another channel prepared. Okay. Do we want to try another switch? We want to try another switch, right? Let me get that other switch. Quinn PoE. We have another switch here, and this one is a classic. I think many of you will have known this switch. It's a Netgear GS105. And to give you an idea how old this switch is, it comes with one of these power bricks. So it's not a switching power brick, it's a really old style well, non-switching, I guess. 12 volt, 1 amp. Okay, let's do it. I don't even know if that power adapter is going to work. This is... How old is this? It's at least over 10 years old. I think it's maybe 15 or even more years old. Okay, so let's power it up. Wow. Okay, seems to still work. Let's give it an uplink. Yeah. Wow. This switch has been off for years. Okay, let's put that on the side. Let's see. Do we... Whoa, the port 1 through 4 are gigabit. And this is 1100? What? Why is it different? I don't know. Let's use port... I don't know. Port 5. That's fine. Yeah, okay. 100. Yeah, okay. I like these separate LEDs. You don't see that nowadays. Now I'm almost sad we're going to blow it up. Right. Okay. So that's working. Is it working? Let's see. Refresh. Yeah, we can refresh the page. So that's working. Okay, we're going to leave this. No, we're not going to leave this in that port. Well, let's see. Does it also work in this port? Refresh. See how fast it negotiates with this switch? It immediately works when we plug it in. So we take it out, we plug it in, bam, Ethernet. Can you imagine while I was troubleshooting, building my own Ethernet on the boards, and I was using the other switch, how confusing that was? Bam, link, works. Okay, we tried to kill it. It didn't want to die. Anyway, so we removed the uplink. We're going to unpower it for now, because we already blew up the port, so we can't turn the port off. We're going to put it in number 5. Can we prop this up somehow a little bit? want to see the LEDs. Oh, here we go. This should work. There, now you can see the LEDs a little bit. So we're now just going to power it up, and it's already connected. And let's see what happens. Go. What? Okay. I saw up to 100 watts on my bench power supply, but now it's up to 8 watts, and likely the PTCs have closed. Meanwhile, the switch is still blinking away on the brain board. So let's see, did the PTCs close? Yeah. So if we look at the thermal camera, we see 112 degrees on the PTCs. Let's try and focus that there. So, okay, so the PTC's closed, so that's the protection mechanism for when there's a short circuit. That's fine. It's been doing that for a while now, so let's turn it off. Let's remove this. And I don't know, let's put the uplink in there. No, that's okay. I don't want to blow up the uplink. Let's put this in here, and the uplink in here, and turn on the power. What? It still works? Okay. I honestly expected it to blow these ports. Maybe not the whole switch, but at least the ports. Alright? Because on my bench power supply, I saw at least 100 watts for like a minute. Oh, well, not a second. Like half a second or a quarter second. Really quickly. And then, well, the PTCs closed because there was too much current flowing, so they closed. Right? Or opened, I guess I should say. But seemingly that protects the ports pretty good. I don't have any more switches prepared. Well, I have one more. There's one I use sometimes over here. This guy. And these are all non-PUE switches. We could maybe try... Oh, this one has PUE. I think it's PUE in. So this is a 260 GS instead of a 250 GS. Well, this works, so we can disconnect that. Okay. Well, we're gonna keep trying different switches until something blows. I don't know. Gotta steal that port protection circuit. Yeah, maybe. Okay, so this goes there. Yeah. Okay. Let's turn that on. Let's verify this is a working switch. I'm not going to use the PUE port for this. Yeah, okay, well, it's already blinking there. Can we refresh the page? Yes, we can. Okay, so this is working. We're first going to try the normal port. Well, I guess we'll try port 2 then. No, let's try port 5. Let's put this in port 3. I don't know. Immediately works. So we're just going to, while it's on, we're just going to plug it in. And remember, the detection circuit is broken. So it's just immediately going to send power. Okay, go. Oh, it's not liking that. Okay. Well, I can already tell what happened. I heard fizzling and likely the PTC's closed. Here, the power is blinking on and off. Oh, now it's just off. Okay, let's disconnect it. Did we kill it? Let's turn the power for the switch off. Might have killed the switch. Might. Okay, let's turn it back on. Nope. Okay, let's this one. Oh, it turned off again. But is it the power supply? Is it the switch? So it briefly powers up and then it powers down. Okay, let's try a different power adapter. Yeah. 12 volt. Okay. Yeah, let me try this power adapter. Okay, so let's try without this guy in here, or this guy. Nope, it's not liking it. This one's dead. Let's turn this on. Wait. No, no. See, oh, it blinked. So wait. Let's give it a little bit. Maybe it needs to air out. You know. Maybe I need a drink. Maybe there's some protections in there or something. Okay. Let's try it one more time. Power. So it powers up. Okay. Oh, there it dies. But that took a long time. Let me see if I can get an uplink while it's doing that. Yeah. So we need to, I don't know, let it cool off for a little bit. The AI overlords are trying to revive it. Yeah, just like in last stream. I don't know. I'm waving it around like it'll cool off, but I'm trying to resuscitate it. Okay, let's see if we can get a uplink on Ether 2. Power. Power's still on. No, Ether 2 isn't coming alive. No, okay. This one's dead, people. We killed it. Okay. Let's take a look inside. Yep. Put it in a bowl of rice. Yeah, I don't think that goes for anything. Yeah, this isn't the official way to open it. Ow. Come on. Wow, it's stuck together pretty good. We're going to use the unofficial way to open it. There. Well, nothing I can see on the back. Oh, okay, this needs to go like that. There. Interesting. Okay. So, let's see if we can see what might have gone wrong. There's a lot of unpopulated components here. Well, easiest thing is probably to just turn it on and then see what gets hot. It doesn't smell burnt, no. So let's take the magnifying lens off. Okay, this heatsink is 41 degrees. Well, it's probably radiation heat, so let's turn it on. There. Oh, what's this? Something here that's a diode. That is 44 degrees. Oh, no, this is it. Okay. Where's my magnifier? Yeah, we found it. Let's see here. This chip here is 130 degrees. That's likely not good. And from looking at it with an inductor here and capacitors and things like that, that is a DC-DC regulator chip. So let's see what type it is. Oh, I don't have my magnifying glasses here anymore either. Well, an LSC. Hold on. An LSC, and now you have to type with me. LSP 5526. LSP 5526. Okay. LSP. It's a what? Oh, it's a diode incorporated. Okay. It's a 23 volt synchronous buck converter. Okay. Well, that blew. That's dead. What is this case rated for? It's rated for 30 volts in, but it's only a 23 volt buck converter? What? How does that work? That is confusing. Oh, well, anyway. Yeah, so it's dead. It died. Likely the others then have a buck converter, which is a higher voltage, so it doesn't die, maybe? Interesting. Okay. Okay. Well, this can go to the graveyard. Wop, wop, wop. Too bad. Okay, so since we now killed that, we have an issue, because we also killed the Diff-Power, or rather, we killed the output MOSFET on the Diff-Power. And I don't believe I have any of the other channels fixed. But I could do so pretty easily. So I need to make a modification to the board to make it work properly. Oh, I want to test one thing first. Does the LED strip still work? Or the output to the LED strip still work? Well, we'll just test if it turns orange. If it does, that's fine. Yep. Okay. So it didn't kill the data. It didn't kill the power. It only killed the MOSFET. Okay. I don't like that, but there's not too much I can do about that, I think. Oh, I didn't share the screen with the LSP 5526 2 amp 23 volt synchronous buck converter. Full power forever. Well, no, it'll work fine. You just can't turn it off anymore. So that means also no hot plugging, because then stuff is going to start dying. Although not as quickly as we saw last week, as I think. Okay, I need to these stupid glasses there. They hurt my ears. Need to take the brainboard off, and then we're gonna remove some resistors. Oop. Because then we should have proper channels to test Diff Solo and Diff Advanced. Because I think Diff Solo will actually be fine. And Diff Advanced might be interesting. Right. So let's see what I need to do here. So here you can see I've already done some modifications. And for that channel, we still need to remove a resistor. Now we'll do it for 2 channels, so we have some channels to play with. I already packed up my Captain tape. So we're going to use this. Scissors. Yeah. So we're going to make a little barrier here. But we do need to be able to get to that resistor. Okay, and it's that resistor and that one. I could take out the microscope, but I'll zoom in digitally. Digital zoom. There. Now you can see the resistor. So it's. Oh, do I have a tweezer? I do. Yes. It's we're going to take out this resistor and that one over there. And we're going to try the brute force it out method. If that's a thing. Let me get my fuse sucker. And we need some flux. Pro engineers only use digital zoom. Well, it's maybe in a few years we'll have AI zoom. So that will be even better than optical zoom. So we're going to put a little bit of flux over here. And over here. Just to make our life a bit easier. Oh. And we might need to put some low 10 solder paste there, but I'm going to try without. Okay. Okay, this guy. No. This guy? Yes. Right. Suction on. This is going to be tedious, but we'll have to deal with it. Okay. It's connected to the ground plane, so it's going to have issues. Come on. Wait, hold on. Yeah, we might need to add some low temp paste to this because it's just connected to the ground plane, so it's not willing to move. Yeah, okay. Yeah, sure, Draadstaal, but even then, those aren't miracle either. Because those still will have issues delivering the amount of heat required to get it loose. The problem is only one leg. The other leg isn't the problem. So I need to get a little dot here. Why is the camera out? Okay. That should be plenty. Let's do it for the other one. Yeah, okay. So let's try that again. Yep, there it goes. Oh, no, it's stuck. Okay. That's one. Yeah. So even with a dual tweezer, you still can't get the heat in there. So I mean, yeah, I don't know if that's really going to help you much. Oh, there it goes. And it's stuck to my soldering iron. See how much easier the second one was when I added low temp paste? There. Okay, so now we should, in theory, have two usable channels again. That's channel 4 and 1, 2, 3, 4 and 5. Yeah. Okay. Now that's a bit nasty with the connectors. So let's do 6 too. So let's add some low temp paste to 6. There. Yep, there he goes. Not sure where it went. Let me check. Oh, okay. It's stuck here. Yeah, okay, got it. Good. That's off too. Okay. So now we can choose channels 5 and 6 as if they were 1 and 2. Good. Okay, let me clean that up real quick. Very good, very good. So now this can go. We can take our brain board again. We lost a screw. Yeah, this prototype has seen lots of reworks. Oh, right, we're still mega zoomed in. Sorry. Okay, let's... There. Okay, brainboard is on, and now we're just gonna get this same plug and put it in here. So now, whoa, there's a loose strand here. That's bad. Anyway, who cares? So now channel 1 is channel 5 and channel 2 is channel 6. It doesn't work that way for the I2C, of course, but they're all going to turn on and off anyway. So that's not a problem. So let's get our trusty working board here. And we'll hot plug it. So, okay, 55 volt. Oh, wait. Power supply. Ugh. Okay, 55 volt. There we go. These channels are stuck on. That's fine. So 1, 2, 3, 4, 5. Oh, we didn't software configure it. No, it's channel 1. Okay, 1, 2, 3, 4, 5. Plug. See an orange light. It's not working as expected. Why not? Are we not sending data? Hold on. 1, 2, 3, 4, 5. What is going on? Let's turn it off. Oh wait. Oh, we don't have a network connection. Oh. There's too many wires here. There. Okay. WLED is up and running. Why don't we have an output? I'm confused. Let's try 6. Okay. Maybe I already killed D5 with something else. It's completely possible. Rainbow. Yeah, okay. So this is working. Let's see if it still turns off. Yeah, port turned off. Hot plugging works. Okay, so this port seems to be doing what it should be doing, right? Can we software turn it off? Well, okay, yeah, we have our delay here. That's fine. Cool, okay. Well, let's take my glasses off again. Right, Diff Solo and Diff Advanced. I need to get some. one extra moment, please. I got some Diff Advanced, but I'm not sure where the Diff Solos are at. Where are the Diff Solos at? Well, that sucks. What? One more second. One more second. Apologies for that. I seem to have misplaced my Diff Solo, which is very interesting. It's too bad because I actually think that was going to work. Let's see if I maybe stored it here somewhere, but I can't imagine it. Seems not. I do not understand. Okay, well, then we'll try Diff Advanced. And, well, I'm pretty sure that's going to die. So, let's see. This is working beautifully, as we just saw. I still don't understand why this isn't working. Okay, maybe... Ah, okay. I have something reversed. I'll need to check on that. Anyway, that's fine. Okay. We'll use this port to send it to the Diff Advanced. Right, so this is a production board, which we're going to kill. No, in. And let's set all the switches to off to start with. There. And, well, I'm just going to plug it, see what happens. Okay, well, that's a good sign. No orange LED. Okay. So, currently, nothing is happening. That's good. But if I enable pair 1, likely actually we could test that. Can we test that? Yeah, I need a second power supply. Do I have one over here? Likely if we only enable... Ah, sure, Mike. Likely if we only enable channel 1, it's going to work, because that's the same data pair. But the problem is, we don't have the terminator plugged in currently. And the terminator might set off the auto detection circuit. So let's plug it in. Yeah, okay, I was afraid of that. Okay. Oh, yeah, okay. Oh, wow, okay. Okay. I'm gonna open a window real quick. Holy shit. Hold on. I'm gonna open the door. Right. You guys wanted smoke. Well, you got it. Smoke jet. Yeah, it blew. So there is a little plastic protrusion there. Oh, it's still hot. It's still hot. Okay. Where it melted out, the smoke wanted to get out. Yeah. So there's 4 120 ohm resistors in here, which of course set off the detection circuit and killed the terminators real quick. Which makes sense. I mean, yeah. And likely, if we enable one of the channels other than channel 1 or pair 1, it's going to kill an RS485, one of the RS485 chip. So we can test that too, because this is linked through. So power always, or data always flows through this, right? But because these switches weren't enabled, the RS485 and the rest of the board is likely still fine. So let's enable power. 55 volt. The port isn't dead. Well, it's also not detecting anything, so it's not turning on. Oh, no, I think it was all the terminator. But let's turn on channel 1. No, nothing happens because channel 1 is the data channel, also in Diff-Power. That's channel 2. Uh-oh. Okay. Got scared. Okay, as soon as I turn on channel, let's turn on channel 3, the detection light turns on. No, this capacitor's fine. It doesn't look bulged or anything. That's an 80 volt capacitor too, so it shouldn't hurt too much. So we're likely gonna now kill the RS485 chip. Oh, the yellow one. This one, no. No, these were all a bit crooked to start with, but this one is definitely bulging because I had to rework the board like 50 times. This one isn't. 2 cents, nice. Okay, we're going to enable pair 4, which is a power pair, and I'm going to sit back. Because that will enable the light. Oh, yeah, okay. More smoke. Oh, it's still on. Oh, okay, it's only doing 3 watts. Something broke, but I don't know what. Oh, well, the switch still works. Sizzle and smoke. Yeah, but what smoked? Oh, wait. I see a little bubble on the RS485 chip. Yeah, that wasn't there before. Okay, let's turn on another pair. Let's turn on pair 3. Okay. Oh, the detection isn't on. The detection isn't turning on anymore. Okay. We're trying to see what will die. And I think we just killed this RS485 chip. Which is logical if you put 55 volt on its input. I mean, that's kind of what you expect to happen. But yeah, now the detection light isn't triggering anymore. I think. A little bit. No. Okay. So, yeah, this killed at least the RS485 chip. And maybe some other stuff, but that's unknown. Yeah, that's a little bit out of spec. Let me actually do something real quick. Let me add a channel in WLED. No, sure. Save. Because now, in theory, this should be working. Oh. Detection. Still no data, huh? What did I do to D5? Let me quickly check something in the schematics. Pink smoke. We didn't have any pink smoke, but we had smoke for sure. Let's see. 1, 2, 3, 4, 5. Yeah, it should be connected to this guy. Oh, wait. Okay. I see what's going on. Save. Really? Still not? I don't understand. There we go. Okay. Okay. Yeah, so I fixed... Okay. So the output channel on the Diff-Power is still fine. You may or may not be in Germany. You just missed magic smoke there. Multiple times there, Johnny. Literally like 5 or 10 minutes ago. Yeah, but that also kind of gives us a conclusion. Diff Advanced is not going to work because you need the terminator, and the terminator is connected to all the pairs because of how Diff Advanced works. So you can't do that because you'll blow up the terminator and or the RS485 chip, right? That was quite obvious earlier where we blew up this terminator. A Diff Solo receiver might actually work if I could find one. I'll look one last time. Because that's only connected to pair 1, which is also the data pair in Diff-Power. So, in theory, that should just work. I'm going to look one last time, and otherwise that's it. Oh, bang. It's not where it's supposed to be. Well, normally I'm pretty organized. But seems in this case not organized enough. Okay. I'm gonna check if maybe I have something on my desk still. No. No. My desk is a giant pile because of all the stuff I've been doing. Nope. Okay. Nope. No Diff-Power or Diff Solo today. I'll probably find them 5 minutes after the stream, but you know. Well, I think we're gonna keep it at that for today. As I said, I'm already a bit tired anyway. But we had some fun blowing stuff up. So for Diff-Power, oh wait, let me go back to the other camera. This board is being fed with 55 volt, and it has 3 times 750 milliamp PTC, so it can output a max of 2.25 amps continuous. And if it outputs much more than that, or a little bit more, but then it takes longer, it'll automatically hardware close or open the connection. So a max of 2 amps will run over this cable basically. But this is very thin Ethernet cable for normal 26 gauge. Running 2 amp over 3 pairs of it, it should be fine. That's, yeah. So we have 2 amps coming in here, which is about 100 watts. It's a little bit more because of the PTCs and stuff like that. But effectively at 25 meter or even maybe 50 meter distance, you should be able to get 100 watts out of it. So if you have a big enough buck converter at the end, and I'll have specified types and etc. We also have this type, for instance, which can do 240 watts. So this, you actually have a 5 volt 20 amp version of this one. Yeah, you can output up to 5 volt 20 amp over a single UTP cable. But basically, if you look at it in watts, you can get about 100 watts effectively out of the buck converter and cable and everything combined. That, of course, depends on distance. If you make a 200 meter UTP cable, well, then you have to downrate it to like 75 watts or something like that, because you'll have to deal with voltage drop over that wire. But in the end, that only lowers the output wattage. As long as you stay above 30 volt, even with inputting 55 volt, the buck converter will remain functional, and well, you'll have output no matter how long the cable is. So it's a combination of distance and power usage. Yeah, okay, well, that was fun. This was genuinely blowing stuff up. 2 switchers survived. Thanks, Benderdict. Yeah, that's the idea. So you can just pull a UTP cable to anywhere you like in your house using a patch panel. That's fine, or in your yard or whatever it needs to go. You can make 50 or 100 meter cables, and it'll send data and power from your central controller to that location. And then at that location, you buck it down to 24, 12, or 5 volt. And run your LED strips over there with a central controller. That is the idea of the system, and it gets even more feature rich in that sense that we can have analog output or digital output boards like this for digital LEDs, but also analog output boards for analog LEDs. Do I have one here? No. Why not? Okay, I have one here. Yeah, no, I don't have one hooked up. Yeah, so we can also do RGBCCT analog output, and maybe more boards in the future. Later there, radiator gummy. Yeah, I'm gonna also, make it a bit shorter stream, 2 hours this time. We did have fun. We did learn a lot. Some switches will survive. Even this old guy over here somehow survived multiple tests. A newer MikroTik switch died. The buck converter gave out. And, yeah. Interesting stuff. So, as I said, Diff Solo would likely have worked, because that only uses the first pair and the rest isn't connected to anything. Diff Advanced, well, you saw the problem with Diff Advanced. It'll put 55 volt on the terminator and then everything dies. And the same if the 55 volt goes to the RS485 chip, then it also dies. So this one is done. Yeah. I like networking, yeah. We talked about it a little bit earlier in the stream. Okay, well, I'm going to let you guys go and go myself. Next week, there is likely not going to be a video because I'll be in China, in Shenzhen, talking with AllNet, doing some testing stuff and things like that. And I hope to be back the week after that. So, thank you all for watching. Thank you for blowing up stuff with me. Some stuff blew, some didn't. Hey. And I'll catch you guys in the next video in the live stream. Maybe on the Discord server. Or here in the live stream chat. Thanks for watching, guys. Bye-bye.